I'm Aiden Flick.
I'm Ben Nelson.
And I'm Raven Crowder.
And we're from Mahtomedi Middle School in Minnesota.
Over the course of learning a bunch about electric vehicles while building our car, we talked with Dr. Leif Christensen, who has been working on developing EV batteries for over 20 years at 3M. And we found positives and negatives of the EV. So positives were there were no tailpipe emissions. Also, they were quiet and had less fill costs and maintenance costs. But there were also some negatives, including the reduced range and filling time.
As you can see, we have a very extensive component list, including a provided battery connector, and motor. We made our chassis out of pine block and dowels.
The final specifications for our car is that it had a length of 34.3 centimeters, it had a width of 15.9 centimeters, and it was 12 centimeters tall. It had a mass of 336 grams, and the gear ratio was 3.44 to 1. Our drive type was a direct drive gear. We also tested a fully drive with parts from a VCR. We raced them against each other. The gear drive turned out to be about twice as fast. Our top average speed was 3.28 meters per second, and our mass with the payload was 1,143 grams.
These are our scale drawings. We made our chassis out of two separate blocks that were connected with wooden dowels. This being the first block with these circles here where the hole for the dowels would be cut. This one was our rear chassis block. It had an extra block right here that would stop the salt canister from going back too far and hitting the gear back in here. It also had a hole cut out for where the motor would fit into the block. This way we didn't have to worry about our motor sliding around at all and disengaging with the gears. It fit snugly enough into there that it did not want to move. We also used some JB weld to hold it securely in place. We had to create an extra little eyelet block that went on behind this rear chassis block. This is what held our eyelet in place so we could have a straight line in the center of the vehicle for the guide wire without interfering at all with the gears. This is what our chassis looked like from the front. We used an aluminum rod, a hollow aluminum rod with a 5/16 outside diameter. We had bearings that fit into the wooden piece that go on the axle on both the front and back to create a much smoother ride. From the rear you can see how the eyelet block fits flush up against with the other block. Our chassis carried the brunt of the weight for the vehicle, with the other parts being mainly for cosmetics and for aerodynamics. And this is what it looks like from the top. We have a tube on here that serves for two purposes. One, it helps with the airflow around coming off the nose cone. And two, it is what holds our salt container payload. We added a yellow nose cone onto the front that we made out of foam core for aerodynamics. For the back, we have a wooden block that fits into the tube, which is where our switch is. It's kind of hard to see, but it's right here. And then our battery. The wiring then goes from there into the battery. This is the view from the right side. And another thing, similar to the team before us, we wanted to make sure ours looked good too. So I wanted to put fins on it with the team on the left. And this is the top.
So we built the chassis out of two 1x4 blocks and cut the blocks using a bandsaw. Here are some pictures of us making the cars, and Then after we assembled those blocks, we drilled axle holes into the blocks and also for the dowel holes. Then attached the motor and the gears into the compartments that we had previously made for it. And then we put in the axles and bearings.
To build our nose cone, we used an electronic cutter to cut 2 pieces of foam and then glued them together. Then we used a bandsaw to carve a cone. Then we proceeded in sanding it to make it aerodynamic. Then we painted it yellow for our school colors. Ta-da!
For the assembly of the tube, we simply used a cardboard tube, and then we cut it to the correct size, and we sliced the slots in it according to the scale drawings. Then we applied a water-based latex paint used by paint to make it to match the school colors. We also created a rear compartment cover by just using a piece of plywood. We cut it into a circle, we drew a hole for the switch, we drew the hole for the electronics, and then we spray painted that blue as well.
For the spinal assembly, we placed the cardboard tube onto the chassis. We had originally planned on using glue to hold it on there, but since it was already snug enough, we decided that it would not be necessary to glue it on in case we had to make any adjustments later on. We then added all the wires. Made sure all our electrical connections were secure, soldered them, and put on our rear cover, which we then securely screwed into place. And of course, we had to add our school logos to it, the Zephyr.
We had many problems while doing this project. As you can see, we crashed a few times. One problem was preventing the gear mechanism from slipping. We designed the rear block to hold the motor more securely. Another problem was connecting the guide wire eyelet. We had to add an additional block to hold the rear eyelet.
Another problem was the gear ratio. We didn't really have time to experiment with the gear ratios, so we used a formula to calculate out what gear ratio we would need in order to get our car to go down the track in 6 seconds. We found out that our gear ratio should be about 3.676 to 1, which was pretty difficult to achieve. We ended up getting a ratio of 3.44 to 1, which worked well.
Yet another problem was getting the guide wire taut enough. We originally had a 4-pound wire, but that was too loose, so we had to use a 30-pound fish line for our guide wire. Yet another problem. The chassis cracked after hitting a wall. We had to rebuild the entire front chassis block.
We learned many things. We learned about teamwork. Everyone's an essential part of the team, and you all need to be committed in order to be successful. We also learned that getting information from a first-hand source, talking to a person, is way better than an internet source or a video.
We also learned that there are 4 key things to making the battery part of an electric vehicle more appealing. 1, we have to increase the capacity. 2, increase the cycle life. 3, lower the cost of the battery. And 4, make the batteries last longer.
We're really happy that we got this opportunity to come to DC to compete in the National Science Bowl.
We're also hoping that by the time we get back to Minnesota, all the snow will be melted.